I am Chuck Aris de Guzman.
I am Rochelle Grace M. Romero. I'm Hanami Olabguban.
In this video, we will show you how to solve about the Pythagorean theorem.
Good morning, everyone. I'm Hanilyn Kaison.
And I'm Diana Jane D. Langay-Langay. So today we were going to discuss the Pythagorean theorems
Of similar right triangles.
Given a right triangle, triangle ABC with legs A and B, and the hypotenuse C, prove A squared plus B squared is equal to C squared. In other words, prove that the sum of the areas of the squares and the legs A and B is equal to the area of the square and the hypotenuse C. But how can we possibly prove that the sum of the area of this is equal to the area of this? Maybe if we could partition the B squared into two rectangles, one equal is area to A squared and the other to B squared. We'll partition triangle ABC into three similar right triangles and use the equal ratios of the corresponding parts in our proof. Draw perpendicular the hypotenuse AB through the vertex of the right angle at C. That perpendicular intersects AB at a point we'll call D. Now we have three similar right triangles. Triangle ABC, the big one we started with containing angle A and angle B. Triangle ACD, the little one that contains angle A. And triangle BCD, the other little one that contains angle B. We know all three triangles are similar by A. Two pairs of equal corresponding angles make similar triangles. Each triangle has a right triangle and all right angles are equal, and each triangle contains either angle A or angle B or both. Reflection, translation, and rotation enable a nice arrangement of our three similar triangles, a reflection across A and C. A translation. Then a rotation. A reflection across DB. A translation. Then a rotation. Similar triangles means that the ratios of their corresponding parts will be equal.
By the cross multiplication algorithm, AB over BC equals BC over BD, BC squared equals AB times BD, substituting A squared equals C times BD. Now we have A squared equals C times BD. A squared is the area of the square on a leg A. C times BD is the area of the rectangle with sides C and BD. Looking at the left triangle's similarity gives us by the cross multiplication algorithm, we have AD over AC equals AC over AB. AC squared equals AB times AD, substituting B squared equals C times AD. And now we have b squared equals c times ad. B squared is the area of the square on a leg B. C times AD is the area of the rectangle with sides C and AD. Putting it together, A squared equals C times BD. B squared equals C times AD. Adding, we get A squared plus B squared equals C times BD plus C times AD. Since A squared plus B squared equals C times BD plus C times AD, we distribute out C and get A squared plus B squared equals C times BD plus AD. We notice that C equals BD plus AD. So we substitute for BD plus AD, giving us A squared plus B squared equals C times C. And finally, A squared plus B squared equals C squared.
In the next video, it is all about special right triangles. Let's watch this and we hope that you will learn.
Hello everybody, how you doing? This is Mr. Dowse. On this video I'm going to talk about special right triangles. This says part 1 because I'm going to have many videos on this. Now, special right triangles are two unique kind of triangles that you're going to come across in geometry. One of them is a triangle that says 45, 45, 90 on it. Now when I say 45, 45, 90, I'm actually talking about the interior angles of the triangle. So we have an example of one right down here. Notice how one angle is 45 degrees, the second angle is 45 degrees, and then the third angle is 90 degrees. This is a 45, 45, 90 triangle because the interior angles are 45, 45, and 90 degrees. Now we also have a 30, 60, 90 triangle. This is the second kind of special right triangle. And again, this is called a 30, 60, 90 triangle because you have a 30 degree angle, you have a 60 degree angle, and you have a 90 degree angle. And so every 30, 60, 90 triangle, you're always going to have a 30, a 60, and a 90 degree angle in the triangle. Now these are called special right triangles because there's a special angle side ratio between the sides and angles. And so this 45 degree angle, these guys are the angles here. And then these x, x, and x squared root 2 are representing the side lengths. So these are sides. And so opposite the 45 degree angle, I'm going to label this side x. And we'll get to x in a moment. I just want you to understand, opposite the 45 degree angle, I'm going to label an x. Now we have a 45 degree angle here labeled x. We have a second 45 degree angle here. And opposite that angle, we're going to label it x as well. And then we have a 90 degree angle. So opposite the 90 degree angle, we're going to label x square root 2. Now this is the side angle relationship. X just means it's some random number. So let's come up with the number 9. I'm just making up a number. So that means since we have this side length is x, and I'm saying x is 9, since this side is 9 here, then I can work my way around plugging in 9 wherever I see an x. And so since I see an x here as well, this guy is equal to 9. And since I see an x here, this x becomes a 9. And so this side length is 9, this side length is 9, and this side length is equal to 9 square root 2. Now I'm kind of jumping ahead here. Again, I just want you to understand that x is just a number here. And so I don't want to go too far into this because then you're not going to quite understand what's happening here. Some of you might be going, why are there two x's here? Why? I don't quite understand what's happening there. Since I have two angle measures that are the same, 45 and a 45, the sides opposite have to be the same. That is something that you just need to know about triangles. If you have two angles the same, you're going to have two side lengths that are the same as well. And so we end up having an isosceles triangle here. A 45, 45, 90 triangle is an isosceles right triangle where I know two sides are the same. And so since if I knew this guy was, like I said, 9 on the last problem, since this is an isosceles triangle, this side has to be 9 as well. And you just have to know that because the angle measurements are the same, the sides opposite have to be the same as well. And then since this guy here is labeled x square root 2, since we know that x is 9, we know this x is 9, so wherever I see an x, we have a 9 square root 2, And so the hypotenuse is the length of 9 square root 2. And we're going to leave this as a 9 square root 2. This is an acceptable answer in geometry. You're welcome to plug this in your calculator, 9 times the square root of 2, and you're going to get some number with a decimal in it, and that's fine. But I want you to understand this is called a special right triangle, because if you know one of the legs on the triangle, one of the sides opposite the 45-degree angles, you can find the other side because it's an isosceles triangle, and then you just take that number and multiply it by the square root of 2, and you can get the hypotenuse. And so let me kind of go over this one more time here. I just want you to understand this before I move on to the 30, 60, 90 triangle. Now again, opposite the 45-degree angle, I'm going to label x. Opposite the second 45-degree angle, I'm going to label x. Opposite the 90-degree angle, I'm going to label x square root 2. Now come up with a random number for x. Let's just say x is 5 in this case. If I know x is 5, that means that I know both of these sides have to be 5 because this is an isosceles triangle. And then whatever one of the sides are here, whenever the legs are on this triangle, I multiply it by the square root of 2 and I get the hypotenuse. And if this isn't enough for you, you can go to my second video, part 2, and that's exclusively talking about just 45, 45, 90 triangles, and that might make more sense for you. But I'm going to jump over to the 30, 60, 90 triangle. The 30, 60, 90 triangle is also, again, a special right triangle because there's a special relationship between the angles and the sides opposite those angles. On a 30, 60, 90 triangle, notice how none of the angle measures are the same. There's a 30 here, a 60 here, and a 90 here. Since these angles are all different, the side measures have to be different lengths as well. And notice how none of these are the same. We don't have an x here and an x here. We have an x square root of 3, and a 2x. And don't get confused here. This is just the side lengths of opposite these angle measures. So every time we see a 30-degree angle opposite the 30-degree angle, we want to label an x. Opposite the 60-degree angle, we want to label an x square root 3. Opposite the 90-degree angle, we're going to label a 2x. And again, let's just say x is 5 again. Let's say x is 5. Well, which side do we know? Do we know the one opposite the 30, opposite the 60, or opposite the 90? Well, we know the one opposite the 30 because x is 5 here. So this guy is equal to 5. Now, since we know what x is, I'm going to substitute in that number wherever I see an x. So this x now becomes a 5. So the side length here is 5 square root 3. And then since we know x here is 5, I'm going to take 2 times 5, and that side length equals 10. And so these are the side measures of this triangle. Now something you might have just noticed. Whatever the shortest side is, or the short leg is on the 30, 60, 90 triangle, we're always just going to double it to get the hypotenuse. And so if this was 10, we will double it, the hypotenuse would have been 20. If this was, oh, I don't know, 25, we would double this, and then we would get 50 for the hypotenuse. And so let me do one more like this, just to help you understand what's actually happening here. Again, I want you to understand that the x squared 3, and 2x are just the ratios opposite these angles. And so opposite of the 30 is x, opposite the 60 we're going to label x squared 3, opposite the 90 we're going to label 2x. And so what we're going to do here is I'm going to come up with another random number for x. Let's say x was, I don't know, 7. Let's say, yeah, just keep it at 7 here. So x is 7. If x is 7, which side do we know? Do we know the short leg, or do we know the side here that's labeled x squared 3, or do we know the hypotenuse? Well, I'm going to label this guy 7 because this is what x is. X is the short leg here, the shortest side on this triangle. Now, what do I need to do to find this long leg, which is opposite the 60-degree angle? I just need to take the 7 and substitute it in for the x, and this length here is 7 square root 3. Now, all I got to do is take 2 times 7 because x is 7, and the hypotenuse is 14. And so the short leg here is 7, this long side here, the long leg is 7 square root 3, and the hypotenuse we're going to label as 14. And so this is how to do the 30, 60, 90 triangle and the 45, 45, 90 triangle. Again, these are special right triangles because there's a special ratio between the sides and angles on these triangles. And if this video wasn't enough for you, check out my other videos I'm going to have on these triangles. Hope this helps. Have a good day.
Once again, I'm Hannah Tyson.
I'm Hannah Mayel Lubguban.
I'm Michelle Grace M. Romero.
I'm Chuck Aris de Guzman.
And I'm Jean B. Lamay-Lamay. We hope you understand.
And thanks for watching.